So good morning, everyone. We're going to continue our discussion on time series. The packages that we're going to use are Tidyverse, Bloom, T-Series Forecast, GG45, MTS, TSM, and URCA. Now, is there anyone who has any difficulty or problem loading TSM? Okay, thank you, Vic. So, yeah, Jerome, thank you. Pag ganyan, class, ang suggestion ko is i-Google nyo. Okay, for example, TSM package does not load. So it will give you some hints. TSM package. So nakay code Z siya. So ito. You can look for this Kevin Kodzi. Siya yung author ng TSM. Right click ko to. Okay, here. Let me share with you this, this site. If you can't find the site, Control C. Okay, Vince, try mo to Kung hindi siya available sa version ng R, there might be another solution. No? Pero generally, ang solution dyan, kasi that particular package, it's possible that it's not loaded sa CRAN, no? Yung Comprehensive R Archive Network. So the authors of packages usually they post it in their GitHub, their repository. So pwede natin ma-access yun. You install the remotes package and then gamitin natin si remotes para ma-install. Magamit yung install.github _github na function. And then i-access natin si Kevin Kodzi /TSM. Okay, Vic and Vince, kindly tell me if you were able to address kasi gagamitin natin si TSM, no? Maraming gamit. Maraming gamit. Okay, nag-restart. Okay. Am I recording?
Yes, sir.
Okay, wait lang. Ayan, okay. So, kanina parang may nag-sound na about recording. Okay. Yeah, thank you. Thank you, Vince. All right, Vic, just tell us if you're mamaya na attendance, if may problem sa pag-install, ha? Okay, so let's continue, class. Okay, Jerome, it worked. Okay, good. Okay, so remember that, class, no? Kapag hindi nyo ma-access yung packages, yung isang package, the most possible reason for it is that it's not in CRAN repository. So you have to check kung sino yung author nun, tapos kung saan nakalagay yung package na yun. Okay, so let's continue. Okay, so I hope you have loaded the AirPassengers dataset. I'll close this first. Okay, load ko siya. This is what we have done last time. And then sabi natin, we can learn more about that package by using the help function. So here's the help function. So monthly airline passengers from 1949 to 1960. Okay, this is from Bucks and Jenkins. Monthly data siya, no? Monthly data. All right, so let's give it another name, just like what we did last time. We used AP just as a shortcut kasi ang haba ng air passengers. Okay, and then I placed parent there so that it can be printed already. So this is the data, the airline passengers, air passengers. Okay. All right, so of course it will be very difficult to understand how your data behaves just by looking at that vector of numbers. So let's also check if there are missing values. Although obviously wala namang missing values, pero just to be sure, we can make use of the sum of is.na just to check kung may mga missing values ba, and it's 0, ibig sabihin walang missing values. Pag sinam niyo yung A and A, wala. No? And then we know that the class of this airline passengers is a time series. TS siya. So ano yung specialty ni time series? Time series can be a vector or it can be a matrix. No? Pag vector siya, whether it's a vector or a matrix, what's important with the TS object is that yung samples na to, they're equispaced points in time. Okay, so let me just copy this and share this with you if you want to. Ay, sorry. Okay. So just to save on time, para hindi na kayo mag-ano. Okay, now let's learn more about the data. Ano ba yung frequency? Frequency can be can be daily, can be monthly, can be weekly, quarterly, etc. So ang frequency nito ni AP is 12, no? So ibig sabihin monthly siya. This is monthly data. And then we can take a look at the cycle. The cycle will tell us, okay, yung structure ng data natin. So this is from 1949 to 1960. 1949 consists of 12 observations. That's divided into January up to December, up to 1960. So that's what we get when we use a cycle function. Okay, any questions so far, class? Difference ng frequency at saka ng cycle. Cycle, of course, is all about the whole data. Si frequency, yung ano lang, and of course, class, magkaka-frequency and cycle lang tayo pag time series. Pag ordinary vector lang to ng characters or letters or numbers, walang ano yan, walang frequency yan. Kasi ito time series, may ano yan may yung data has a definition of the time component. Okay, clear so far, class? Paki-chat naman, no? Okay, good. Feel free to ask questions, class. Okay, so let me close this. Okay, we can also use the summary function. Alam natin yan. The summary function will give us minimum value, first quartile, second quartile, third quartile, also the average and the maximum. Okay, the mean here is 280. The median is 265, which means that medyo nakaskew tayo to the right, no? Yung mean, ibig sabihin, mas maraming mga values din sa right side. Okay, kaya yung mean, the values, more values on the right side, pull the mean to the right, not 280. Okay. So we did this last time. We can make use of the plot function, plot AP, and then you can just add this descriptors ng data, yung ylab natin, yung date, xlab I mean, ylab is passenger numbers in thousands, and let's just name the main as air passenger numbers from 1949 to 1960. Okay, and if I plot this, if I run this, we'll have this plot. Okay, I'll give you a few seconds to type that. Lot ng object AP. Then we define the X label, the Y label, and the main. So when we plot this, you can see here that the title of the main plot is air passenger numbers from 1949 to 1960. Tapos may label yung X-axis may label yung y-axis. Okay, kindly chat please if you were able to get this. Waiting for your confirmation, class, if you were able to plot.
Sir, pwede pabalik po dun sa code.
Okay. Thank you for meeting. Okay, chat please. Okay. All right, thank you. Okay, so we can see here that yung nature ng data natin, there is a trend as discussed last time. May trend siya, no? It's going up and there is seasonality. May peaks at regular intervals. So may mga peaks at saka troughs. Okay? So sabi natin last time that we can know usually tinitingnan yung trend, yung seasonality and cyclicality. But cyclicality is difficult to identify kasi it usually takes long periods of time. So mahirap makita yung cyclicality. Okay, so all right. Now we can use si GG plot 2 at saka si GG45. They're really more powerful tools for data visualization. Okay. Si GG plot 2, hindi natin pwedeng gamitin kapag data frame yung object natin. So kailangan ipa-partner natin siya with GG45 para ma-plot pa rin natin kahit na data frame lang yung object natin. So here, pareho lang yung ang syntax, medyo konti lang pagkakaiba. I'm using autoplot, okay, AP, and then yung label natin labs, X is equal to, Y is equal to, and title is equal to. So very convenient dito, kasi pinag-isa sa isang parang umbrella yung labs or labels, X, Y, at saka title. Okay. We'll get almost the same. Difference lang ng konti sa format, sa form. If I run this, and that's what we're going to get. So once again, I'm going to give you a few seconds to copy-paste na lang siguro, tapos medyo baguhin nyo na lang. And paki-chat please kung okay. You get the same plot. Only that we're using here yung autoplot. Kasi mas powerful talaga class yung ggplot. Si plot function, very limited lang siya. Hindi pa nga natin linalagay yung color schemes dito. Just a simple use of the autoplot function. Okay, good. Thank you for your responses. Let me check unless may questions. Wala naman. Okay, thank you. Okay, thank you. All right, so let's now use the box plot. Familiar naman kayo sa box plot, di ba? Natutunan niyo yun sa basic stat nyo. Diba? I hope you still recall. The box plot looks like, di ba, this one? Okay. Meron tayong yung box dito, di ba? Tapos yung mga whiskers niya. Tapos may line dito. This is the median. Okay, I won't anymore really discuss yung what a box plot is kasi it's from your basic statistics. So let's just run this. Box plot, it's similar to the plot. May X label, Y label, may ang naiba lang, AP, and then associated with yung cycle ng AP. Diba, if you recall, yung cycle ng AP consists of yung mga, yung frequency, January hanggang December on a per year basis. Okay, so if we run this, okay, so this is the box plot that we're getting. Okay, kindly chat please if you were able to get the box plot before I continue discussion. Okay, very good. Okay, thank you. Okay, pero halos wala pa nakaka 50% na. Ayan, halos 50% na. No? Let's give a few more seconds to your classmates. Okay, what can we see from the box plot? What do you notice about this class? First, ano yung mga numbers dito, yung 1 up to 12, nasa x-axis? What does that refer to? Months, okay. Yes, you're correct. Months siya, no? Months. No? So this is January and then this is December. So ang ginawa dito, kinolect lahat ng January ng 1949 hanggang 1960. Kinolect siya, tapos kinompute yung median, tapos kinompute yung quartile 1, quartile 3, then yung IQR, which is just the difference of quartile 3 and quartile 1, and then you multiply the IQR by 1.5 and then subtract and then add sa taas. No? So what we can see here is, based on the plot kanina, di ba sabi natin may trend. Dito naman sa box plot, makikita natin talaga yung seasonality dito. We can see here that the highest median is month 7. Tapos highest points are month 6, 7, 8, 9. Sila yung medyo matataas, no? Pinakamatataas yung medians nila, pinakamatataas yung ano nila, yung highest points, ito yung mga maximum. Although there are no outliers, no? Wala mga dots dito sa dulo or dito sa baba. But we see how month 6, 7, 8, 9 dominate the other months, no? Okay, and we can only surmise that this is due to sa US data to no? Summer to mga months ito. Okay, summer yung mga months. All right. So, let's continue. So, ano yung mga inference natin so far about what we have seen dun sa plot at saka dun sa box plot? Number 1, kita natin increasing trend over the 12-year period. Okay. Number 2, we already stated this one that there's seasonality present and that can be shown dun sa peaks and troughs. Makikita natin yung regular na pag-akyat tsaka yung pagbaba, consistent siya. And then the highest median was on July, month 7. And by virtue of the highest points and the highest medians in month 6, 7, 8, and 9, they were the ones that meant people were traveling a lot more from June, July, August, September. Okay, they had the higher medians, higher variances compared to the other months. Okay, and sabi ko dito, ang data natin multiplicative. Okay, anong difference, class? What's multiplicative? Plot ko ulit dito yung ano. So let me plot first here. Okay, plot ko to. Okay, notice that for our data, okay, asan yung okay, pag multiplicative class, you notice that yung seasonality niya, I'm just exaggerating, it's increasing over time. Diba? Yung difference dun sa peaks at saka sa troughs, lumalaki na lumalaki. So it's increasing over time yung seasonality natin. Kasi pwede ang seasonality ganito lang. Yung constant lang siya. Hindi siya increasing over time, hindi siya decreasing. So it's just constant over time. Now this one is called the multiplicative time series. And this one, on the other hand, is called the additive, of course. Hirap ng digital pen. Additive. No? Multiplicative versus additive. Okay, clear yung class? Pause muna ako. Clear? Okay, let's wait for the others to give their comments. Feedback. Okay. Let me clear this first. Okay. So multiplicative, additive, kaya sinabi ko dito. This one appears to be multiplicative time series. Kasi increasing over time yung yung seasonality niya. As distinguished from an additive na constant lang. May seasonality pero constant lang yung galaw. And I mentioned a while ago that there are no outliers, no? Wala mga dots dun sa mga above the whiskers or below the whiskers. Okay. Any questions about this initial inference class? Okay. About the rest? Clear tayo so far, ha? Okay. Thank you. Okay, so we learned this also in the past that time series can be decomposed. Meron kang time series, pwede nating i-decompose into its trend, its seasonality, its cyclicality kung meron, and then some random or irregular patterns, so random numbers. Yung hindi kaya ma-explain ng trend, ng seasonality or ng cyclicality, papasok siya dun sa random. No? Okay, so let's make use again of the okay, so balikan ko lang yung kanina yung multiplicative, no? So yung multiplicative, sabi natin, we can model the time series using this model, multiplicative time series model, which is just you define your time series x sub t to be the products of your trend, yung seasonality, and you can include here C kung meron, no? If ever there's C. Bigyan natin dito times C underscore T times, and then we're bigyan natin dito control C, control V, where C is the cyclical component. Okay, so let me just share this with you so that you don't have to write it. Okay, of course, class. Of course, lagyan na natin dito, no? Para control C, control V, the additive naman. No? Additive. Additive is, of course, just replace. Okay. All right. So, define natin yung yung mga parameters na yan. Okay, so let's first try the multiplicative time series component. I'm creating here an object called decompose AP. Decompose AP. Pwede kong baguhin ko na ito. Decomp AP underscore multi. Okay, so multiplicative yung kunin muna natin. Control D. Okay, so I'll give you a few seconds to write that and run that. Write and then print natin yung decomp AP multi. What do you get? Ano yung laman ng decompose na object? How many elements does it have? I'll wait for your chat in the chat box. My question is, when we decompose our time series, in this case AP, whether into multiplicative or additive, okay, how many objects will R generate? In that class? All right, thank you, Jerome. Thank you, John. Yeah, you're correct. 6. No, 6 objects siya. If I run this, control enter, and then dito sa ilalim, makikita natin sa sa mga data natin, kasi list yan, kaya under data siya, hindi siya under values. Ito, decomp 80 mult 6. Ano yung mga laman niya? Yan. So you have X, the values itself, the original values. And then, ito na yung decomposition niya, no? Break down siya into the seasonal index, the trend, and then the random component. And then figure is for your multiplicative index, no? And then type is multiplicative. So, if you see this, di ba? Ito. $X, ito yung decomp AP underscore mult. $X, ito yung original data set. Tapos the next one is $seasonal. Okay, tingnan niyo itong seasonality. Ano ibig sabihin ng 0.91 sa 0.88 sa 1.007? It means that is multiplied to your the value of the trend at that time, 0.91. So trend. So itong mga multiplicative indices to. So you notice, si March, this will be above the trend kasi ang factor niya 1.007. So January, February, April, May are all below the trend. No? Si June, 1.12, 1.11. July, August. And you can see here that dun sa multiplicative index, multiplicative ano natin, time series, dun sa, if we're going to use a multiplicative index here, si June 1.112, 113, si July 1.23, si August 1.22, si September 1.06, above the trend line pa rin. Pero si October, November, December, below the trend line na. So we can see here that July really has the highest multiplicative index factor. Kaya mataas talaga siya sa July, no? Based on the model. Okay? Then going down, tingnan natin iba pa ang laman nitong decomp nito. Andito si trend. Okay, 126, 131. Okay, ang question, bakit walang trend nung first 6? At saka wala rin trend nung last 6. Why is that so, class? Wala yung 1949, January up to June, wala siya. Pero 1949 na July up to December, meron. Okay, tapos, yung July to December ng 1960, ito, wala siya. Okay, bakit wala, class? Any guess? Ano kaya, class? Any guess? Why no first 6 trend figures for 1949 and no trend figures for 1960? Last 6 months. Okay, I see an answer here. Okay. Lawrence, i-share mo nga yung answer mo sa lahat. Lawrence, kindly share your answer. May answer din dito si Vic. Yung lag. Okay. Well, technically, pero yung last 6 months ng December, hindi naman lag yun, di ba? Okay. So, kasi class, bago ang pag-compute dito ni R, para makuha yung trend na figures, remember that trends are forecast in themselves. So sa 1949, yung trend ng January hanggang June, wala kasi kailangan niya yung past 12 na values. Okay, so it has to have the past 12 values, at least past 6 values, no? Para makuha yung trend from January up to So wala tayong data ng 1948. Okay, so hindi niya ngayon makuha yung trend ng first 6 months ng January, first 6 months ng 1949. Tapos yung sa din, ganun din, yung sa July, kailangan din natin ng 6 months na before, advance na after. So wala. Si July, August, September, October, November, December ng 1960, wala pang values dun sa nauuna sa kanya. So hindi rin pwede kunin yun. So that's the answer why we have NAs nung January up to June ng 1949 kasi nga wala yung past 6 values. Tapos si 1960, July, August, September, October, sorry, this is So June ng 1960, July, August, September, October, November, December, that's 6 months also. So hindi rin siya mape-predict. Okay? All right, so I hope that's clear. Okay, balik na tayo dito sa tuloy natin to. Okay, so ayun yung trend, ano? These are the trend values. Okay? So yung mga trend na yan, class, imo-multiply yan sa ano, no? Sa index. Okay? At saka sa random. Yung random natin, asa yung random? Ito. These are the random figures. Okay, and then, yung figure dito are just the indices, no? Indices for January, February hanggang 12. January, February, March. Yung June, 1.11. July is 1.23. August is 1.22. So, ang pinakamataas talaga si July. Nagsispike up dyan. Pati si August. And then, baba na ng September. Okay. 1.06 is still above the trend. No? Pero itong November, itong month, October pala to, then November, December. October, November, same baba, no? 0.08 dito. And then December. Okay, any questions, class? And then type is multiplicative. All right. Any questions? So clear itong multiplicative. Tingnan din natin itong si additive. Palitan ko na lang to, no? Decomp na lang. Decomp AP additive. Okay, so I'll run this. How will the additive function look like? Okay, so ito si $x, ito yung actual value. And then take note, tingnan nyo itong mga factors sa index ng additive, no? Okay, ito na yung mga i-add, no? So for the months of June, whatever the trend is, i-add to. Okay, the trend will be the line. Tapos i-add yung negative 24, kaya nung January bababa siya. February mas bumaba. Ito yung mga troughs. Ito yung troughs natin, pinakamababa. Then March, April, makiat ng konti, pero still below the trend. May, tapos biglang from negative 4.5, naging 35.4. So you can see the drastic change in the month of June. Tapos from 35 sa July, 63.83 yung idadagdag. So you can see there immediately a difference of mga almost 30,000 passengers. July and June are almost the same. Then September, baba na naman. October are negative siya naman. Okay. And then this is the trend. This is what's to be. Depende kung multiplicative the times. Pag additive, i-add to. And then you have here the okay. Sorry, trend pa rin to, no? Sorry, trend. And then you have here the random. Ito yung sinasabi ko sa inyo, no? Ito yung i-add. Sorry kanina, trend. Yung trend class, yun yung baseline natin, di ba? So, whatever you find here, kunyari yung seasonality, i-add yan sa trend. Okay, tapos, yung random, ganun din, i-add. So, may mga i-add, may mga isa-subtract. So, it depends on the year, kung ano yung random, depends on the year, and also of the month. Kasi yung random class, di ba? Tignan nyo to. Yung January ng 1950, mag-a-add tayo ng 8.49 or 8.5. Okay, pero January ng 1956, magbabawas ng 1.2. Okay, so these are, as the name suggests, random siya. These are random values. And lastly, the figure is the additive components, additive indices, and then additive siya. Okay. So pause muna ako, class. May I know if you were able to get it? Kindly chat, please. Okay. Let me see kung okay so far. All right. So, ano ko lang tong comment ko dito, no? You may wish to put that there in your notes. Control C. Control V. So, meron main components is strength and seasonality. The rest, cyclicality, if ever may nakikita yung model natin, or yung random component, meron din yan. What I meant was cyclicality. Meron. Okay. So, we quickly review yung ginawa natin last time, yung regression din, di ba? So here we create an object, a data frame, AP data frame. So magka-create tayo ng data frame, kailangan natin yan kasi sa regression, kailangan may data frame tayo. No? So I'm using the data frame function. I'm defining time as 1.1 to 1.144. And then yung AP natin, kasi may AP tayo, di ba? Dito, yung airline passengers natin. Okay, so pareho silang size, length. 144 yung time, 144 yung AP, okay to. So if I run this, APDF, Apple data frame, we now have this one, APDF. If I click this, it will print now our APDF object here. Andyan yung time hanggang 144, andyan yung AP. So what we're going to do now is regress AP on time. So this one, let's plot first. Plot APDF type is equal to L line. So we get the same plot. And here we're plotting the data frame itself. Okay, so you may wish to, if you don't put anything here, kung hindi nyo linagay yung type, ang magiging default yan is a scatter plot. Scatter plot siya. Or if you want, kung gusto nyo yung mga points nyo sa type, yung mga points nyo dun sa line, yung exact points may mga bilog, no? You can use this. And you can see here the circles. Ito yung dun sa place ng actual data. No? That's type O. If you don't put any type, then it will just be a scatter plot. So let me revert back to L. Type is equal to 1. Pwede rin naman ganyan. Let me just stick to L. Okay. All right. Once again, please don't get tired responding. Questions, please, or okay tayo so far? Up to this point, nag-create tayo ng isang object ng data frame, no? APDF. Ang laman niya, dalawang columns, dalawang variables, yung time at saka yung airline passengers. Okay, so when we plotted that, ito lumabas. No? Which we expected kasi pareho lang naman yun. All right? Okay, so let's continue. Mag-regress tayo. Let's just call it mod 0. Model, and it's our linear model. AP regress on time. Data is equal to, gagamitin natin yung data frame, APDF. Otherwise, hindi natin pwedeng gamitin yung mga vectors. Okay, and then summary ng mod. Okay. So pause muna ako. I'll wait for your feedback. If you were able to get it, kindly chat yes, please. No questions? Okay. So I hope everybody's getting it. Thank you. Okay, so if you take a look at the model very quickly, ang model natin is our model is very quickly yung intercept. That's so our time series is AP. Ano ba ginamit natin? APDF sub T, right? APDF sub T is equal to our intercept 87.65, no? 87.65 plus 2.66 times what? So, times time. Time 2.66 times time plus a certain error term. Okay, so that's our equation, no? And significant kasi yung pareho, di ba? Significant. And overall goodness of fit test, let me close this. Unless may questions ba dito sa equation? Model natin itong data natin, APDF, right? Naglalagay ako ng sub T kasi to indicate that that's a time series. And it's equal to 87.66, the intercept, plus 2.66 times time. Okay. So in a sense, OLS nga pala ito. Okay, and then, let me clear the drawing. Escape. And then dito, we can see that overall goodness of fit test, okay, there. Significant naman yung mga, at least one of the predictors. And then the R squared is around 85%. So this is quite high, mataas, 85%. Considering na timeline ginamit natin na predictor. But we don't stop there, we have to test, no? Check natin kung kamusta yung residuals natin. Okay, so I'm going to share with you this code. This will actually create an autoplot of AP and then may ipa-plus tayo yung geom smooth. Okay, ano yung geom smooth? So depende sa method niya, ito ang ginagamit natin, method is equal to LM. So gagawa siya ng smooth line with confidence intervals, no? Dun sa plot natin na AP. And then may label tayo X, Y, at saka yung title. So if I run this, okay, so it's just the data and then naka-superimpose yung regression line. Okay, any questions here? Plus? Okay, my question yata. Okay, now thank you. All right, how about the others, please? So far ba nagawa nyo itong data natin, tapos yung regression line ito? So another one. Okay, so you can see here that as expected, yung trend ang makakapture ng regression line, but not at all any of the seasonality. So yan ang weakness class. That's why we don't use OLS sa time series, especially kung yung time series. Buti sana kung yung time series natin, parang linear trend lang talaga. But this one, kikita natin yung increasing variance over time, di ba? May fanning out. Lumalaki yung variation ng data natin as we increase in time. Okay, so pag mag-diagnostics tayo dito, so let's do that. Let's have some diagnostics. All right. So I think we discussed this before, but I'm going to create this object called mod0.diagnostics. And then let's use the Broom package with the function augment. Okay, so let me first run this to mod0. Yun yung model natin kanina, yung regression model natin. And then augment. The augment function will create a table consisting of several important parameters. Okay, I'm going to run this. So ito siya, no? Andyan yung fitted. Andito yung residuals. Okay? Andito yung actual value. Andito yung dependent variable natin. Andito yung independent variable. Andito yung predicted value. Andito yung residuals. Okay? So the most important ones, and then standardized residuals. Ay, sorry. And then let me just print this again. This time round ano lang, 3 decimal places para mas maliit. Okay. As I was saying, ito yung actual value, predicted value, residuals. Okay, and then let's plot, since this is just a simple linear regression. Okay. So ggplot ulit tayo. Ipa-plot natin si model 0, diagnostics. Kasi table to, di ba? Data frame to eh. Ang ipapaplot natin yung time at saka yung AP, yung actual point natin, plus mag-G yung point tayo. No? Ibig sabihin, G yung point yung pag-plot dito. And then, mag-ano siya ng smooth, no? Yung LM, and then yung geom segment. Ipa-plot niya yung geom segment, i-connect yung actual data point at saka yung fitted line. Okay, if we run this, so that's how this model looks like. This plot looks like, not model. So we can see here the actual data points, di ba? Yung mga black na yan. Tapos the red lines are your residuals. Okay, so makikita natin na itong model na to, as we said, it's not an ideal model. It's not a good model because hindi niya talaga nakaka-capture yung yung seasonality, which is prevalent as far as time series data is concerned. Okay, so parang hindi yung model, hindi siya ganun kaganda. Even if the R squared, as we showed a while ago, is 85%, di ba? Yung sa regression line natin, 85% yung R squared, yan, 85.36 or 85.26 yung adjusted. So that just tells us that R squared should not be a parang absolute basis kung maganda yung model o hindi. Okay, any questions with that, class? I'll give you a few seconds to run that. And then paka-comment na lang. Go up. San Vic? Here. Dito ba, Vic? Sa may Broom?
Up, sir.
Up pa. Up,
Up
sige.
sa up. A
Sige
little
lang.
more. Yun there, sir.
Dito? Sige.
Yeah, just gonna check kasi nag-error sa akin.
Okay, sige. About the others, any questions? Nakuha niyo ba tong ano, yung augment na function where it will create a data frame consisting of yung mga key elements sa ano sa residual diagnostics? Vic, okay na? Nag-run na ba?
Hindi nga sir, yun yung,
Let me
um,
let me copy
yes.
this. Pero ano lang naman yun eh. Yung iba naman kasi title lang yan eh. Label lang yan. Did it work? Bakit kaya? Dali ah.
Tapos, right now,
Can you share your screens para makita ko?
sige sir.
Dali. Saan ba yung stop sharing?
Sir, yung error na sa ano, Geom Smooth sir.
Dali ah. So,
Same problem, sir.
let me see. Saan ba yun? Oh, saan ba yun? Hindi makita yung share screen. Hindi, not that. Ba't hindi ko siya makita? Saan yun? May kaso. Hindi naman sa apps. Isa na nga ba yung where I will ask you to share your screen? Hindi ko makita. Okay, sorry gentlemen, hindi ko makita eh. Ano ba yun? Bakit? Ano? Bakit? Mamaya na lang ha, mamaya na lang after. Anyway, plot lang naman siya. Sino ba nagkaka-problem doon? Who else? Hello? Who else is having a problem there?
Me, sir.
Me sir, me and RJ.
Ano yung problem sa'yo, RJ?
Geom smooth.
Same din sir.
Geom po, sir.
Wait. Did you install ggplot? Linoad yung tidyverse, no?
Yes po.
I-load nyo nga si ggplot2. Pati gg45, linoad nyo naman, di ba?
Yes po.
I-check nyo muna, i-library nyo ulit. Library ggplot2, tas library gg45, just to be sure. Ano pala? Yan, nakita ko na sa share pala. So, sige nga, ano, pa-share yung screen. I just want to see the error. Carlos, Vic, pa-share yung screen.
Sige. Sige sir, wait lang. Hindi ako connected sa laptop ko eh.
Sino pa?
Naka-separate ako.
Sino pang isa? Si Jerome? Can you kindly share your screen, please?
Okay po, sir.
Sir, ggplot 45, no?
Hindi, GG45, not GG
Ay, GG
plot 45.
sorry.
Okay lang po ba, sir, kung mas
Sorry? Hello? Okay, sige, mamaya na lang kasi nasasayang oras natin na. Mamaya na lang after the class na lang kung hindi pa nag-work yan. Is my screen sharing?
Yes,
Class?
sir.
yes, sir.
Okay, sige. Yung mga may questions sa plotting mamaya na lang. After the class na lang. Alright, so as I said here, class, hindi magandang model to kasi it doesn't capture any OLS done on a time series will really not be a good model kasi may mga usually ang time series may mga may mga of course may trend. Yung trend okay lang. But volatility, seasonalities hindi nakaka-capture ng ng time series ng OLS. Okay, so tinan din natin class yung diagnostics, no? This is just to reinforce what we showed here. Graphically, yung errors, yung residuals. Ikita natin na kaya may ganyan mga residuals. Kasi nga, yung OLS natin, yung trend lang, ito lang, yung blue lang yun. Diba? So, if I run this to, partition natin yung yung plots ng model 0, which is a regression model. You can see this one. I haven't checked your paper, but I hope you use this sa diagnostics nyo. And we can see here that dapat dito, pag walang heteroscedasticity, yung red line na to, dapat halos sumusunod lang sa straight line na to. And here you can see the plots ng mga residuals, no? Kitang-kita yung heteroscedasticity dito. And there are outliers here. May outliers dito. Although dun sa two-key approach, yung sa box plot, sabi niya dun walang ano. Iba kasi yung pag-compute dito ng outliers, iba dun kay two-key. So ganun din dito, using the square root of the standardized residuals, okay, you can see here the pattern of heteroscedasticity, yung fanning out. Okay, non-constant yung variance. And then here you have PQ plot, which is a measure of the normality of the residual. So dito makikita natin, we observed it a while ago na yung mean natin is far to the right of the median. So talagang dinadrag ng data natin yung maraming data na nasa right, nasa right side. As you can see here, diba? The presence of extreme data to the right. Okay, ganoon din tong residuals versus leverage. Alright, you can also use this. Pwede natin gamitin to, no? Ito, plot, model 0, and then use which. And it will just plot individually yung apat na to. And then we can have 6. Ito kasi ano lang apat lang yung kaya niya. No? Kahit nagawin natin tong, kunyari, no? 2 by 3. Ibig sabihin 2 rows and 3 columns. Or, gawin natin, sige, 2 by 3. Ito. Let's see what happens. So, 5 lang yung generate na na plots. Ito yung una. Tapos, yung to the right is the normal QQ. Tapos ito, yung kanina pinakita. No? 5 lang talaga. No? When in fact, that plot can give us 6 plots kasi yan. So, which is equal to 1. Ito yung una. No? Then which is equal to 2 will give us the QQ plot. Which is equal to 3 yung standardized, square root ng standardized residuals. So ito yung leverage for, Cook's distance na. No? So there are candidates, 139 is a candidate for an influential data point. Okay, and number 5, yung kanina yung residuals versus leverage, and then number 6, another one, Okay. Cook's distance versus leverage. Okay, but sa time series kasi iba talaga yung model na ginagamit natin. We will not discuss this. Okay, nakuha to class yung diagnosis ng konti. So I just illustrated here that the OLS was not a good approach really to model your time series. Graphically, makikita natin dito na hindi talaga nakaka-capture yung mga yung mga seasonalities. No? Okay, so there's another method, a more powerful method, and that's your ARIMA, autoregressive integrated moving average. I-place natin yung sarili natin para sabay tayo ng kabilang section. No? Okay, so how can we use this? As I said last time, this was developed by Box and Jenkins in 1976. And there are certain considerations for us to be able to make use of ARIMA. Number one, dapat yung data natin stationary. So we have defined what a stationary data series is, diba? Time series. Sabi natin ang time series ng stationary has constant mean and constant variance. When we say constant mean and constant variance, okay, yung properties ng time series natin does not depend on time. Okay, so time series siya, pero yung properties natin, kunyari mean at saka, mean at saka variance, does not depend on time. In other words, kahit na anong time frame mo titingnan, hindi nagbabago yung yung average at saka yung variance ng data natin. Okay, those with trends and seasonalities are not stationary. Okay, the trend and seasonality will affect the value of the time series at different times. Siyempre, kung may trend ka, if you take a look at a different period and get the average of the value of the time series at that point, iba na. No? Either mas mataas na siya or mababa na siya, depende dun sa trend. And also the seasonality, tumataas. No? Yung variation ng data natin, tumataas o bumababa, depende. Okay, so we can do, so di ba visually tinignan natin, and we saw visually that there's trend and there's non-constant variance. Okay, the good thing is that we can definitively say kung stationary siya hindi using statistical test. And the statistical tests to do this are marami. No? May unit root test, may ADF test. So some of the, tumingin lang tayo ng 2 or 3 ngayon. Ha? So one is the augmented Dickey-Fuller test. So sa augmented Dickey-Fuller test, ang tinetest dito is if the null hypothesis natin, the series is stationary. Or not stationary pala. Okay? Okay, so prinat ko lang ulit to. Dapat dito ko sana dito. Control X. Hindi, okay lang pala. Hindi ko na i-run siya kasi naran naman natin. Ito na lang, no? Statistical test for your stationarity ng time series natin. And we're using the T-series package. And the function that we're going to use is ADF.test. ADF.test ng AP object natin. And we find here, okay, augmented Dickey-Fuller test. Data AP, ang stat natin, Dickey-Fuller statistic is negative 7.32. P-value is 0.01. Ito yung kailangan natin dito. Okay? And what does this tell us? Kasi ang alternative hypothesis natin stationary. So the null hypothesis is not stationary. We reject this. Oh, wait, no? P-value is 0.01. So we reject the null hypothesis that AP is, oops, wait. Bakit ganun? Alternative hypothesis stationary. Therefore, null hypothesis is not stationary. Okay. All right. AP is, tama ba? AP. Right. AP. Tama, oo. Now, ito na experience ko minsan, ano? Sometimes, dito sa ADF test na to, you get some weird results. Okay, kaya minsan, pag nagkakaproblema ako dito, I use another test. Kasi dito, alam naman natin na yung plot ng AP will tell us that the time series is not stationary. And yet, when we use this ADF dot test ng AP, okay, p-value natin is 0.01. So, it's much less than 0.05. Therefore, we reject the null hypothesis that the time series is not stationary. So, ang sinasabi ba niyan, stationary time series natin? Okay, so there's something wrong there. We know that the series is not stationary. Okay, so tingnan naman natin to isang test, no? Nawiwirdoan lang ako dito kasi I've done this several times in the past. Sometimes nagkakaroon ng weird na solution. Okay, let's use this. Ito muna si KPSS test. Okay, there's another test. Itong KPSS test, no? These are the names of the people, si Kwiatkowski, Phillips, and two others. No? Nag-develop sila ng ano. So this is coming from the URCA package. All right. So ito naman ang null hypothesis natin dito. The time series is stationary. So this is unit root. Unit root dot KPSS. KPSS are the 4 people who generated this, who developed this statistical test. Tingnan natin. Summary ng UR, KPSS, and AP. Let's take a look at this one. Okay, ito tama, class. Okay, let's take a look at this one. So dito, ang tinetest sa unit root. I'll explain unit root in a while, no? May time pa, baka hindi na, baka next time ng unit root. Basta ang unit root, ibig sabihin ng class, basta may unit root, hindi stationary. Okay? So the time series is stationary, KPSS. Okay. So ang binibigay dito yung KPSS statistic 2.7395. And then ito, yung critical value niya is 0.463. So what you learned in your basic stat is that, di ba pag binigay yung critical value, okay. Okay, so here you have your critical value, which is, sa 5% level of significance, this is 0.463. And then the t-stat is 2.7395. Andi dito siya. 2.7. So itong area na to, beyond the critical value, this is your rejection region, di ba? So therefore, ang conclusion natin using KPSS test is that we reject the null hypothesis dito. Ano yung null hypothesis dito? The null hypothesis here is that ang data natin is, close ko lang to. Okay. Based on the KPSS test, stationary yung data natin. Okay, therefore, lagay ko na dito, no? Compare the KPSS value with the critical value. If the KPSS value is greater than the critical, then we reject the null hypothesis. So meron tayong conflicting results dito, no, class? So kaya nga minsan nagtataka ako dito sa ADF test eh. Ulitin ko nga ito kasi medyo tingnan nyo. P-value is 0.01. So we reject the null hypothesis na hindi siya, not stationary siya. So ibig sabihin stationary siya, which is wrong. Ito naman, KPSS test. Okay. It's already time, class. Just 1 minute na lang, Okay. So KPSS test is stationary, and then ang gagamitin natin dito yung KPSS statistic. i-compare natin ang ginagamit natin na level of significance yung 5%. Okay, and lastly, ito lang class, no? I'll explain this further next time. Ito. Unit root test din to. Okay? yung kanina, UR.KPSS test. Ito naman, UR.DF. If I run this, okay, Dickey Fuller test yung ginagamit dito, no? Pero ibang package. And then here we have, all right. So I'll explain next time ano ibig sabihin itong z.log1, no? Yung probability na to. Okay? So it's already time. So ganun din, di ba? Tingnan nyo to. Value of the test statistic. Tapos yung 5%, negative 1.95. Ang question, asan to? Nasa critical region ba to? Okay? Alright, so let me stop there, class. And we'll continue with this next time. Next time, tatapusin na natin tong yung ARIMA. And kindly do some readings about, just do some readings about ARIMA, ano yung equation niya. Kasi next time, pupunta na tayo sa kindly do some reading about ACF and PACF, and then ARIMA, and then we'll finish this lesson. Saan tayo sa class next meeting? Okay, so stop recording now.